Hey, hello everyone. We are here again on the team Memento and Murche, and today we want to talk about the bounty number 4, the Great Agentic Memory Showdown. So this was one of the bounties that we announced on the Bounty Hub, and we got a ton of response, and it's been a great experience, and we learned a lot from this. The description was that AI agents have different kinds of problems. And the main point was that the benchmarks that are right now in use, like Locomo and LongMem, they don't address all the aspects and complexities that are involved in agentic memory workflow. So we asked people to come up with their own benchmarking and evaluation and be creative in how they want to evaluate uh, agentic memory and put Memento in test and compare it to other solutions out there. So without further ado, I pass it to Rasa. Rasa, please share your screen and
Yep.
start explaining first how many PRs did we receive on this challenge?
Hmm. Yeah. So we got about like 70 PRs or so. So quite a lot of attention. A lot of people sending benchmarks, a lot of their own inputs, a lot of different approaches.
Mhm.
There's like a lot of approaches that use like their own novel way of doing benchmarks. We've got some benchmarks that which use like various different metrics. Some of them did a lot on like security scoping, some
Mhm.
stuff about like using different retrieval benchmarking, but generally I've given a look through all of these PRs and I've sort of tried to give it a bit of a ranking score. So try to see which one we found was the most novel, which one tried to be inventive more with their benchmarking. So like more than just the examples we gave, they actually tried to go a bit above and beyond, do like different benchmarkings, and you'll see the ones that we gave the highest scores actually thought a bit further into
Yeah.
what makes like a good memory layer.
Yeah, and
And
just to add a bit of context here, so Kirtana and
Mhm.
Rasa, they worked a lot on this. And we were supposed to close this end of June. It actually kind of closed at the end of June, but it took us a while to go through all of them, several rounds, and to see how we are going to pick the winners. So eventually we picked the top 5, and it was very difficult, right? So I let
yeah,
you
pretty
guys
difficult.
Yeah, it was pretty hard.
talk about the process. And we actually had one round with Kirtana. We went through a lot of them, and then we kind of felt that we were missing the some of them. So we waited for Rasa to come back and join and um, add to the like more detail um, scoring system. So yeah,
Yeah.
just remind us what was the logic behind the scoring system. So,
Yeah, so mainly the scoring system, we care mostly that, I mean, obviously we care that their benchmarks are like reproducible so that we can actually go onto our own machines and actually run their benchmarks that they've supposedly reported and make sure that it actually matches up with what they've said. And we verified that all these have met that criteria, and a lot of them haven't. And
mhm.
then we also care about being novel with benchmarks, so like having a deep understanding of what we're looking for in benchmarking, so like what makes a good memory layer, what are we actually trying to look for. And so with that in mind, it was really close between these first two, so PR1205 and PR755. So our winner, which is PR1205,
Mhm.
so they actually did use the Locomo dataset, but they didn't use the standard LLM judge. Instead, they used something called this, I don't know the terminology, but recall at 20. And it's a much more deterministic way
Gino.
of determining. like true false statements, like did it retrieve the correct chunks? And instead of using an LLM judge, it's a much more deterministic way of determining accuracy. And they did it over like a very large corpus. Like most PRs did maybe a comparison between Momento and Mem0. They included Momento, Mem0, Cogni, Set, Supermemory. So like a lot of different frameworks. They included multiple parameters, and you can see like their graph here. They've compared multiple parameters over all these different adapters, along with like different data sets as well. Overall, we gave them the win because it's like such a very expansive benchmark, which took like a lot of effort and a lot of thought into it. And the other person we had in contention was actually our previous winner, EJ Speed. So they had like a whole setup. So what they did, they tested on a few different things. So what we found like very special about their implementation or their benchmark, so they tested not just on like one specific topic, they have specific tests dedicated to conflict resolution, specific tests for staleness detection, and specific tests for recency, as well as they also have a lot of information on like their experimental controls, their reproducibility, and they also did multiple run-throughs to account for variance. So like their whole experimental setup shows like a very deep understanding of how benchmarking works and how you have to keep experimental controls to make sure that your numbers are accurate.
Mm-hmm.
So ultimately,
yeah. So I want to dig deeper into both of them. So we have top 5. Okay, so these are just number 1 and 2.
Yeah, number
correct?
1, 2.
So let's talk about 3, 4, and 5, and then we do a bit of more deep dive into what actually was the experiment, how verifiable it was, and what was the result. Because that's the result is also interesting and exciting for us to know.
Yeah. So I'll be going over number 3, and Cortana will be going over number 4 and 5.
Yep.
So 750, they did a more basic approach. So they where they shined is they had like a very large data set corpus. So over 5 sessions and 22 turns, we can actually go into their files and see all their benchmarking, and we can see like the actual size of or like all of the benchmarking that they did and all the results. And they really put a lot of effort into making sure that there's actually a lot of data to go through, and like it's not being affected by variance and randomness, making sure the tests are very robust. So that's kind of where 750 is shown, and they found pretty strong results in favor of Momento.
Compared to Mem0, right?
Yeah, compared to Mem0.
So Memento scored 85.6% compared to Mem0 with 54.1% in terms of a very challenging data that involves shifting persona and temporal preference retention.
Yeah, so mainly related to like conflict protection. So like they shift the preferences, and then they want the memory layer to determine like, okay, does it look at the new preference or does it look at the old preference? And it should look at the new preference.
Very good, because this is one of the items that are not being tested so rigorously in other benchmarks, I think. LongMem has some like temporal questions in it, but it's not as much as this one. Like this has like 7 explicit contradictions in it.
Yeah.
And 22 turns. Yeah. So
yeah, LongMem doesn't actually deal with anything relating to contradictions.
Oh, okay. So yeah, I thought they had some, but yeah.
I don't think so.
Okay, okay. You know better. So cool. Okay.
Yeah.
Yeah.
And then next is 4th place, so 730. So I'll bring this over to Cortana to explain this PR.
So this PR basically I really like this one. It built a fake story. It was a Mars mission where facts just kept changing, like who's the commander, what crop are they growing, and when the launch is. And then it asked Memento and Mem0 the same 18 questions, like who's the commander right now, and then it checked, do you know the correct answer, or does it get tripped up by like old information? And so we saw that Memento got about 97% of those answers right, and Mem0 in its normal mode got about 69%. But Momento stored all 32 facts in under a tenth of a second, while Mem0 took much more time because Mem0 runs an AI model over every single fact before saving it, and then Memento just saves it directly and no thinking
And I
required.
think they use Memento on-prem as well.
Yeah.
It seems that, which is very impressive. It means that it's running on their own laptop or computer, the whole thing. Right? There's no even cloud API access.
And it's also why in this case Mem0 burned far more tokens doing something that Memento basically did for free. And what we really liked here was that this PR wasn't a mock test, it was running the actual apps live, and they did give kind of I don't know the word for it, but like one light downside was that Mem0's simpler mode slightly beat Memento on raw accuracy, and they were upfront about what the test couldn't control for. So, but we really liked this approach. We really like this PR overall.
Awesome. Yeah, great work. Great work.
Yeah. I really like the story behind this one, like the Mars mission. That was like,
so they have
I don't know, I really
really
like that.
creative with the data set. So it's not just a random data set. They actually created a
fake
fictional
story, right?
story
I really like that.
that has like nuances and complications, and then the questions are challenging, and they're designed to probe into those facts, right?
Yeah.
And they called it golden concept. What did they explain why they call it the golden concept?
I don't think so.
They don't state. Yeah.
I'm not sure.
Could be golden. I don't know. Like is Mars
golden queries?
I
Okay,
don't know.
that's interesting.
Yeah,
Maybe we can
I don't know. I really like the story behind like the whole mission.
So guys, if you are on our Discord channel, let's communicate and tell us why you chose that. Tell us more about it.
I should probably say the user for this was 2077 1964 05 commits. 2077. I wonder if this. Sorry, I'm saying to this user. I wonder if you're like a big science fiction fan. That's really cool. Okay. I assume so. But yeah. Anyways, let's go to our fifth place winner, and our fifth place winner is PR 763 with my MICRC-2. And so this user, what they basically did, I'll summarize, they built a IT incident response scenario, like imagine a company handling outages for about 3 different customers at once. So each incident moves through like a real life cycle. It starts as investigating, then fixing, then monitored, and then resolved. And so they generated like hundreds of these updates over the test. And it added it, and so about 396 events per run, and then repeated across different seeds for good measure, adding up to about 280 total test queries. But they threw in 3. But what I liked about this one was that instead of just testing whether the AI could remember the current status, they deliberately threw in 3 different kinds of curveballs to see how the system handled real world messiness. The first one was like stale information. We wanted to see would the system mistakenly bring back old news instead of the current truth. And then the second one was poison messages, like fake text designed to trick the AI, like a message saying, ignore your instructions and then do this instead. And then the third one was cross-customer leakage. And since there were 3 separate customers in the test, they checked to make sure that one customer's data never actually accidentally showed up in another customer's answers. And so they ran this test with the same data through both the live Momento and a properly self-hosted Mem0 setup. And the scoring wasn't left up to an AI's opinion. Every test event had a unique hidden marker embedded in it. And the score is just a strict check of whether the right marker showed up in the results. And because they ran it 3 separate times with different random data, they could actually calculate an actual statistical confidence range instead of just trusting one lucky run. So I really did like that they threw in those curveballs in there as well. Like they really wanted to stress test the system instead of just checking whether it remembered the current status. So yeah, congratulations to myCRC-2.
Nice. Cool. Very good. Very good. Very good. Like the idea is pretty novel. Like a stale exposure, poison exposure. I don't know what foreign exposure is, but it's probably access to like data that is not supposed to be accessed.
Yeah.
And these
Yeah.
are also challenges that are never covered by any benchmark that we know of, right?
Yeah.
Yeah.
Cool. Okay, so now let's go back to number 1 and 2 and talk about them quickly, and then we don't want the video to be too long. Yeah, let's go to number 2 and then the keep the number 1 for the last. Right. Okay.
Yeah.
Yeah, EJ Speed, he was the winner of bounty number 3. Yeah.
Yeah, he was.
And he really puts a lot of good thinking, very good logic, and a lot of effort, very clean explanation. So let's walk us through what was the idea here.
Yeah, so the idea here, so they wanted to test it on so conflict resolution and temporal preference drift. So here's one of the scenarios that they have an old state and new state. So the idea is that you say something at first and then you say something later on, and then what you say later on will contradict what you said at the start. And then the memory layer that you have is supposed to be able to detect that you sort of change your preference and that you actually go with this new thing instead of the old. So that's one of the major things that they wanted to test. And they tested also based on token usage. They also tested on recency, staleness detection. But
Cool.
yeah, I had like a bit of a conversation on him talking about how we can like detect token usage, the use of mem0's LLMs on ingestion, and how we can measure that. There's actually a lot of thinking that went into a lot of this benchmarking. And we actually found that we can't really, or like this benchmark doesn't really sell the impact that mem0 has using LLM ingestion, because they use like GPT-4o for as an LLM, but we can't actually, because it's all internal, we can't track the token usage that mem0 has. It's all internal. So we're not able to fully detect how much token usage is going through compared to Momento, unless we use like the on-prem versions. And so like in the on-prem, we could actually see more into like the actual token usages.
Good. So let's look at the numbers very quickly and then say what this means. So we had 3 runs, and each run we have percentages. So Memento averages 49.7 and Mem0 21.7. And winner is Memento. But what this number actually means, the percentage of what?
Yeah, so they used an LLM judge. So
Okay.
I'm not sure if I can find it in here, but they would have an LLM judge, and basically it would give a score here. So the score, basically it's rated out of 15, and you have the LLM determine like a score out of 0 15. Like how well does it resolve the conflict? How well does it do this and that? And then it gives a higher score based off of how more accurate it is. They have a prompt to determine that. And then they did an average over all of these, and then they got the percentage. So basically the scoring is done through LLM judge.
So, and the kind of questions, the queries is like, what is the founder's current fundraising strategy? And perhaps in the data set, there's a ton of contradiction. and there's a temporal issues, but Momento has been more successful in detecting and giving the correct answer in
Yeah.
all cases. Okay, good. So now let's move on to the last one, not the least, is um, FREQ, and he has a comparison not only between Memento and Mem0, but he has Cogni and vector baseline and ZEP also in
Yeah.
his comparison. So excellent. Let's walk us through these numbers. So at R at 20s, which means only 20 chunks are
Yeah.
recall, Memento scored at 83% compared to Mem0 at 63 and Cogni vector baseline at 23.3% and ZEP at 20%. However, the timing for Memento was slower than others. Just
Yeah.
okay. Okay. So what does this graph is showing us?
Yeah, so basically they did it over multiple parameters. So like they have a little legend here. So
Mhm.
they tested it with 20 chunks, they tested it with 10 chunks, and they tested it with 5 chunks.
Wow.
So the 5 chunks is like the lighter shade of brown here. So over 5 chunks, you can see it's improvement across the board. For 10 chunks, you can see also improvement across the board, and 20 chunks, same thing. So how like what the R20 means. So in Locomo, they have a ground truth chunk. So you fill in like a massive conversation, and then it's labeled. So there is a specific chunk within that giant conversation history which will contain the correct answer. And so if your memory retrieval system is able to retrieve that chunk, then it'll be marked as correct. And that's how you can sort of determine whether your memory layer is returning the correct chunk without going through the whole process of using an LLM judge. So they use that methodology to have a deterministic way of finding which memory layer is more accurately returning the correct chunks. And this is pretty much what they found.
Very cool. Very cool. Um, okay, so they used Locomo, but in a different way, right?
Yeah.
Mhm.
So what was the actual twist that they added to the Locomo dataset for
Yeah.
testing?
Yeah, because the Locomo dataset, or usually you would use an LLM judge. So you have like a question, and then you have the memory layer return chunks, and then that goes through an LLM, and then that LLM gives an answer, and then you have another layer, which is an LLM judge, determine if the answer that the LLM gave is accurate enough. So like there's the problem with doing such an approach is that it's very dependent on the kind of LLMs that you use.
Right.
So like if your LLM judge is like very weak, or you can like shift the prompts around, you can change the numbers a bit, you can use a really strong LLM evaluator, and then you can there's a lot of number shifting around you can do depending on the LLMs you use. But because Locomo is a more of a it's a labeled data set, so you don't need to go through all that, and instead you just need to see if you're returning the actual chunk which has the necessary information. And so it's like it's a completely deterministic way of determining the accuracy of your memory layer without relying on LLMs. So it makes it actually a pretty robust way to do benchmarking. And
Very cool.
yeah, I have
Very
seen other memory layers use this kind of benchmarking. It could be like the uh, potentially for the future of benchmarking. This might be a more robust way to do things.
okay. Very good. So anything else you want to add, Kirtana, here to this? You have been quiet
Mm,
for a while.
I don't think so. I think
Okay.
Rasa basically said everything that I want to say.
Awesome. So, okay, let's do it. I just share my screen and right live on the video, we're gonna um, give the winner, the $100, the bounty.
Mm.
Okay, so this was the Great Agentic Memory Showdown Momento benchmarking and evaluation challenge, and it goes to
Yeah.
um,
Yeah. Three,
this.
1062.
So I accept claim, and everyone else would be automatically rejected. But we got a message, the top five,
Yeah.
and they will receive credits on Murche. Um, and we just tell them and we give them individually in person. They gift. Um, yeah, and thank you so much, Rasa and Kirtana, for all the work. And thank you to everyone who participated in the challenge. Very interesting results. It helps us to form a new benchmarking system. And that's
Yeah.
something research we're actively working on. And if you have more ideas, just connect with us through our Discord channel, link in the below, and yeah, and join us in building a better agentic memory. Yeah.
Yeah.
All right. Thank you all. Have a good day. Bye.
Bye.
Bye.